The Pythagorean Theorem. This is a digital lesson. So it starts out with just explaining to the students what the theorem is and gives students the formula a squared plus b squared equals c squared. So a and b are going to be the two legs of a right triangle. C would be the hypotenuse. So students are given those three vocabulary terms. And on the next slide, they're just going to type in either hypotenuse or leg to label these two right triangles. Now students are given an example of how to solve for one of the missing sides of a right triangle. So we're going to use that formula a squared plus b squared equals c squared. With a and b are the two legs, c would be the hypotenuse. Now when they get down to step 3, they have c squared equals 100. So to solve for c, they have to do the opposite of squaring a number. They have to take the square root. And so they take the square root of both sides of the equal sign, and they get c equals 10. So the hypotenuse would be 10 centimeters. Now students are going to be doing this on their own. They're just going to type in the text boxes. So here we get 3 squared plus 4 squared equals c squared, and they're going to solve for c. So the first few problems, they're just solving for the hypotenuse. When they get to slide 9, the answer will not be a perfect square, so the answer will just be a square root. Same thing on the next one. And now they're going to be solving for one of the legs using the same formula. So a squared, we don't know what a is. We're going to solve for a, one of the legs. Same thing on the next slide. And when they get to slide 13, now they've done it with the text boxes, they're going to do it on their own on scratch paper. So here they have a right triangle. They're missing one of the length of one of the legs, and they're just going to solve for b. Same thing on the next couple slides. And then we explain to the students the converse of the Pythagorean theorem. So the converse says we have a triangle. How do we prove it's a right triangle? So we can prove it using the Pythagorean theorem, a squared plus b squared equals c squared. If this works, if it comes out equivalent, we know it's a right triangle. So here's an example of how that works. Now students are going to be looking at these 4 triangles, and they're going to place an X in the box next to any that are right triangles. Now here's a diagram. Students are going to determine the hypotenuse here, which would be the diagonal of the rectangle. Here we have a right triangle in a coordinate plane, so we're going to just use units. So here would be 3 units and 4 units, and they're going to figure out how many units for the hypotenuse. Then we have a real-life example here. So we have a ladder placed against a wall, and how high up is that ladder? Well, we know the ladder's 17 feet, so that would be the hypotenuse. We know it's placed 8 feet from the wall, so we have one of the legs, and then we have to determine the missing side. Now, the final part of this lesson, we're going to prove the Pythagorean theorem visually. So we have a right triangle. We have the length of all 3 sides, and we're going to create a perfect square here along each side. So if this side is 3, we have a 3 by 3 square, a 4 by 4 square, and then the hypotenuse would be a 5 by 5 square. And we're going to show that the area of each of these two squares is equal to the area of the larger square. And they're going to do that on the next slide. So they're going to take each of these pieces and they're going to place them in the larger square. And they're going to find out that they're going to use every single piece and it will fill up that, the larger square. So they're going to click and hold. They're going to use this little blue circle and they're going to turn that square so that it fits. They're going to do that with each of the pieces, and they're going to find out they're going to use every single piece to fill up this larger square. And that will prove the Pythagorean theorem visually. So that is a digital lesson, the Pythagorean theorem.